Nowadays, only the oxy-steel and electric arc processes are relevant. In the oxygen steel-making process, the liquid pig iron is transferred into another ladle. The temperature is measured, samples are sent to the laboratory, and the floating slag is removed. The liquid pig iron is now poured into a converter. Subsequently, scrap is added. This is to control the temperature increase due to oxidation of impurities, mainly carbon and silicon. By means of a water-cooled lance, pure oxygen is blown into the bath. The impurities are oxidized to slag, floating on the bath surface. Finally, a bath temperature of 1650 degrees centigrade is obtained. At the end of the oxidation process, samples are taken for chemical analyses. Within 5 minutes, the results are presented on a screen in the steel plant. From the analyses, also the amounts of alloying elements and reagents for desulfurization and deoxidation are determined. Alloying elements to ensure a steel composition related to the final properties and use of the steel. By using aluminium, the steel is deoxidized. The steel is killed. The aluminium associates with oxygen, improving ductility. These elements will be added during tapping of the steel from the converter into this huge ladle. The ladle is placed under the converter. Steel and slag are poured out of the converter separately. Tapping, first the steel. After that, the slag. The liquid steel is then stirred using an inert gas, argon. This to ensure composition and temperature to be homogeneous throughout the ladle. In addition, the gas bubbles float out impurities, which are absorbed into the slag. After refining, the ladle, now containing about 300 tons of liquid steel, is taken either to a continuous casting machine or, like here, emptied into ingot molds.